So this section, we're going to talk about solving quadratic equations using the quadratic formula. And we saw how to use the square root property in the last section. And so what this section ends up doing, it takes a general quadratic equation, ax squared plus bx plus c. They go and do some operations to make that into a perfect square and then solve it. When the dust settles, this is the formula you get when you solve it. And this is known as the quadratic formula. And so what we can do is we can just identify A, B, and C, and then we just plug into the quadratic formula. So let's see how this works. Let's take a look at example 1. So the first thing we have to do is identify A, B, and C. A is the coefficient of the squared term. In this case, that'd be 1. B is the coefficient of the x term, so that'd be negative 3. And then C is the constant term. So that would be negative 5. And then wherever I see a B, I'm going to replace that by negative 3. So there's two negatives here. This negative comes from the negative in the formula, and then this negative is from the number itself. If I then look at my A, I've got my A here and here, so I'm going to plug in a 1. And then my C is negative 5. I'm going to plug that in here. And now we're just going to start working on simplifying this. Well, double negative is positive, so that's 3 plus or minus. And I'd recommend doing here is just taking that whole thing that's underneath the square root. By the way, we call that the discriminant. The b squared minus 4ac under the square root is called the discriminant. And let's just go ahead and do it on our calculator. We just don't want to make any mistakes here. So I'm typing in exactly how it appears. So that gives us 29. And then 2 times 1 is 2, so that's just 2. Square root of 29, we can't simplify that, so we're pretty much done. So just keep in mind, this means two different, this means, or let's say it this way. There's two different ways we can write the answer. Sometimes you'll see they'll keep it all together, but they might separate them out. So, or what they might do sometimes is they might write these fractions out individually. So they might go ahead and rewrite this as 3 over 2 minus square root of 29 over 2 and 3 over 2 plus square root of 29 over 2. Either answer is fine. You just want to pay attention to what they're asking for in ALEX to see which form they want. So let's try number 2. So again, what I'm going to do here is I'm going to identify A, B, and C and plug in. A here is 1. B is also 1. Now, if I put 3 down here for C, I'm going to run into a problem. I'm not going to get the right answer. Because notice my formula. I have to have it solved for 0 first. If I put a positive 3 here and plug in, I'm not going to get the right answer. I have to first subtract 3 from both sides to get 0 on one side. So it's important you do that first. So that tells me I'm actually plugging a negative 3 here for C. So again, whenever I see a B, I'm going to put the 1. For A, I'm going to put in 1. C, negative 3. And now we're going to work on simplifying. So this would be negative 1 plus or minus. Let's grab the calculator. And let me put it over here. So we have 1 squared minus 4 times 1 times negative 3. That looks like 13. So this would be the square root of 13 over 2. And again, that can represent two different answers. I can represent my answer this way, where I keep both answers as an entire fraction, or I can split them apart. Sorry about that. So again, you can keep them together as one fraction or split them apart. Again, just check to see what they prefer you to enter in Alex. By the way, some folks were asking about these erasable pens. These are the pens I'm using. So if you have any interest, they're kind of expensive, but I really like them because I screw up all the time. It's nice to have something to erase with. And the college does not endorse this product. So that's my little disclaimer. All right, so let's go and move on. Let's take a look at number 3. So I want to be using the quadratic formula here, and I'm just going to recopy it down here. You will have the quadratic formula on your formula sheet, so you don't have to have it memorized. You just need to know how to use it. So if I'm looking at this, A here is 10. B is negative 1. C is negative 3. So I'm going to plug all those in. So taking the 10, I'm going to plug it in where A is at. So here and here. B is negative 1. That goes here and here. And C is negative 3. And now we're going to work on simplifying. So double negative is positive. That's 1 plus or minus. And let's go ahead and do that on our calculator. So that's 121 over 2 times 10 is 20. Now, some of you may realize 121 is a perfect square. In fact, I can take the square root of 121, and that gives me 11. So I can go ahead and I can simplify this further, saying this is 1 plus or minus 11 over 20. I actually have a number that's not irrational, I can go ahead and I can actually break this apart. This means x equals 1 minus 11 over 20, or x equals 1 plus 11 over 20. Well, 1 minus that's a negative 10. That's going to reduce to a negative 1/2. Or for you fans of decimals, you can do negative 0.5. Just be aware that Alex a lot of times is going to ask for the fraction form. And then this would be 12 over 20. And we can reduce that by 4. So that would be 3/5. So my two answers here are negative 1/2, comma 3/5. Let's try this next one. Now remember, we talked about before I do anything, before I try plugging the quadratic formula, I need to have 0 on one side. So my first step is I want to subtract 3x from both sides. It's going to give us 3x squared minus 3x plus 5 equals 0. By the way, something I should mention here, you notice how I got fractions for my answers, that I didn't have any square root stuff or any i's here like I had back in these two. That means this problem is actually factorable. So the nice thing about the quadratic formula, it will give you the answers whether the original quadratic formula is factorable or not. And so it's a more general method. It will solve the ones that are factorable, but it also will let you solve the ones that are not factorable. All right, so we're playing with our quadratic formula, so let me write that down. So I'm just recopying the quadratic formula just so we have it. So my problem, a here is 3. B is negative 3. C is positive 5. And so we're going to pull out the quadratic formula. Let me just draw a line so it doesn't blend in. Okay, so plug in a equals 3. That's going to go here and here. Just identify them up here. I'm going to plug in b equals negative 3. C is 5. So this will give us 3 plus or minus. And let's go ahead and work out what we got underneath the square root. So this would be a negative 3 squared minus 4 times 3 times 5. Ooh, it's a negative 51, so we have square root of negative 51 over 6. Okay, now the problem we got here is that's a negative number, so we have to write that in terms of I. So 51 cannot be broken down underneath the square root. So that's our answer. So again, I can write it this way. Slide up here a little bit. If I decide to separate these out, I'll need to, when I put the 3 over 6, I can reduce that to 1/2. I can't reduce the 61, or the 6 with a 51. Let me write this way. Put the I behind. Always double check when you're putting these in, just to make sure that you're including the I where it needs to go, so on and so forth.